Okay, thank you. Hello, hi, namaste. This is Surabhi, your master teacher of chemistry at Vedantu. Welcome to the session, everyone. Good evening. Hello. Hi, Srilata. Hey, Aditi. Hi, Sudarshan. Hey, Suchi. Hello, people. Good evening. Hi, Sanvi. Hey, Vijay. Hello. Oh, it's very cold, no? है ना? Hi, Shantanu. Super duper excited. I am also super duper excited to teach you. I'm good, but not liking this cold. I know. I'm good. Thank you. Thank you, Ji. Thank you, Sukada. Hi, Shriya. Please reply to your question. Which one? Which one? I do like winter, but I don't want to get out of my bed and work. Hi, Aryan. Hey, Janavi. Hello, Nishant. Okay. So, shall we start before that? Hi, Paras. Hey, Mrinal. तो शुरू करूँ? हाँ. Yes, of course, we'll do that. I don't have that option, Sanvi. What to do? Okay. So, wanna join us? Gain 100% knowledge and score 100% marks. See, and one more thing is, it's fine even if you don't score 100% also, because I really feel that gaining knowledge and learning something new every single day is very, very important. So marks is important, but not that important, right? So unlimited live classes with fun and high level quizzes where you will be competing with the students throughout the world. Yes, so Vedantu mein we have students from different countries too. You know that, right? Interactive replays and live quizzes. So usually in YouTube what happens is, of course, if you couldn't attend the mentee and all that, you can't go back and play, but in our platform we have that option. So for some reasons you couldn't attend the session, or there were overlapping of sessions, you couldn't attend it, so even when you are watching the replay you can actually play the live quiz and leaderboard, so that you can know your overall ranking and score. So for that, you also, after the sessions, after every session you will get the downloadable notes with handwritten points of your master teachers, and assignments will be shared with you people, and tests will be conducted regularly. And along with that, once you get this pro subscription, you will get 5,000 plus micro courses. Micro courses are my absolute favorite. So free crash courses when the exams are near, you want to revise the whole syllabus, so we will help you do it. Less is more. What is less is more? So more classes, you need to pay the lesser price. So for that, what you have to do is just visit the link given in the description box as well as in the pinned comment, and use the coupon code SURPRO. SURPRO, that's my coupon code. A maths and all that, I'm not gonna do it. You people do it. Okay. So 2159 if you are taking 200, if you are attending 200 sessions. So per class price hoga 11. So 600, then it is 9 rupees per class. 9 rupees mein what will you get? 9 rupees chocolate aata hai. हाँ, dairy milk. Okay, yes, that is it. The coupon code is SURPRO. टिप्स है क्या बायो में? नो. हाँ, लेस पैकेट. So learning objectives, today we will be learning something new. So electrolysis, we know, right? We have learned oxidation at anode, reduction at cathode. But have you ever wondered, if we have two cations, then which one will undergo reduction at cathode? It depends on what factors. Have you thought about it? Yes or no? Hi VJ, you're my fab Hello, 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 hello. Hi, Srinivas. Hi, Tirupati. Hello. Relative electrode potential. Very good. You have not thought about it, no? Acha, ab socho. Because I'm going to explain it to you today. So, preferential or selective discharge of ions at electrodes. So, when two or more ions of the similar charge, that is, we have X plus, Y2 plus, of similar charge are present in a solution of an electrolyte under identical conditions. Okay? So it is present in the same electrolyte, obviously voltage, the electricity pass same hoga, no? Then there will be a competition for the discharge. Like, yeah, X also like, I want to go near cathode and I'll get reduced. But it's like, are you kidding? So I'll go there first. So which one can discharge, can selectively discharge? So it depends on few factors. What are those? That is what we will be studying in today's session, along with some very simple examples. You guessed it. Very good. Come on, give me a high five. Hi Janavi. So one of them gets preferentially discharged. So which one is it? And it depends on what factors. So selective discharge of ions depends on three factors. So the relative position of ions in the electrochemical series. Now what is this electrochemical series? We know what is reactivity series. Metallurgy may we have studied. Now what is this new series called electrochemical series? What is this? That's okay. I'm from Karnataka. Do you remember me? Yes, I do. Come on, tell me, what is this electrochemical series? I'm good, Ji. Thank you. So the relative position of ions, how we have placed the metals based on the decreasing order of their reactivity, no? In the same way, we have a series for ions, okay? So it is the ease of discharge increases when you go down the series. So obviously Ag plus can get discharged easily compared to H plus. Got it? This is what is electrochemical series. Electricity plus chemicals. So the second point is the relative concentration of ion. See, for example, if I have taken NaOH plus H2O. So if it's an aqueous solution or very dilute solution, so obviously the H plus or OH minus ion concentration will be high. So if it is a very concentrated solution, then Na plus and OH minus concentration will be high, right? NaCl plus H2O, then Cl minus concentration will be high. So the relative concentration of ions with similar charge, that is the second factor onto which the selective discharge of ions depends on. The nature of electrodes. So we have two types of electrodes, right? Active, inert. So many questions, no? Okay, hi Akshay. So this is the electrochemical series. So next I'll show you the few tables of few reactions in electrolysis. So then you need to compare its position in the electrochemical series and answer, so which ion gets discharged. Okay, ready people? Yes. Will you answer? Acha, OH will be more than H. Okay then. Let's look at the first reaction. इसके लिए mnemonics. होगा. Okay. So the relative position of ions in the electrochemical series, that is the first factor. So if all other factors are constant, so we have three factors in total. So the rest two are constant. Then what happens is, and any ion lower in the electrochemical series. So this is the reaction. We have CuSO4. You will get Cu2 plus SO4 minus 2. So as it is dilute, then we will have water 2. So H plus OH minus ion. So you have SO4 minus 2, OH minus 2 anions, Cu2 plus and H plus. So which one gets discharged at cathode? Can you tell me looking at this series? Yes, come on. Cu2 plus या H plus? Tell me. Cu2 plus or H plus? You know its position in the electrochemical series. You can see it right now. Hi Dakshita. Cu2 plus pakka. Lock karo. Sure. 100%. Then don't say ayyo, oh, all that. H plus. Cu2 plus. Lock. Computer ji, Cu2 plus lock कीजिए for high five. Okay, let's see. What about anode? Anode में क्या होगा? Very good. So ions migrating to cathode, we have Cu2 plus as well as H plus, right? But the ions which get discharged at cathode is Cu2 plus because it is in the lower position, right? Yes, lock it. Okay, come on, give me a high five. Good job. So the next anode part where an anion gets oxidized, so two ions are migrating, that is sulfate and OH minus. Okay, let's have a look at the electrochemical series. We have sulfate here and OH minus here. Which gets discharged? हाँ, high five दे दिया मैंने. Come on, which gets discharged? You can see it right here. OH minus? Anji? Yes, paka? For sure. Okay, very good, because we know that the ion which is present in the lower position in the electrochemical series gets discharged at the respective electrodes. No high five for this, huh? Very good. Got it, people? First factor understood? Yes? Let's do one more. Shall we? Yay or why it is? Huh? Okay then. Cheating? I didn't promise an high five, right? I didn't. Okay. So we have H2SO4. So you will get H plus, SO4 2 minus, OH minus. So the only cation is H plus. So obviously no confusion, no comparing it, nothing. So H plus se discharge hoga. But you have SO4 2 minus, OH minus. So obviously OH minus gets discharged. Got it? Hanji? Okay. Next one. You tell me. Let's not look. I'll write the reaction. NaCl, Na plus Cl minus, H2O, H plus OH minus. So which ion gets discharged at cathode and which one gets discharged at anode? Come on. At cathode, first cathode, ठीक है? Cathode, हाँ. You want me to show you the electrochemical series? Electrochemical series देखना चाहिए आप? चाहते हो आप? Yes, H plus, पक्का? Confirm? Fast. Cathode Na plus H plus. Yes, both the ions are migrating towards cathode. But which one gets discharged? Na plus or H plus? That's the question. Not sure. Okay, so Na plus is here, whereas our H plus is here. Obviously, H plus gets discharged. See, so in the brine solution and all that we know, right? So chlorine gas at anode, hydrogen gas at cathode. We didn't get sodium metal there. है ना? Hydrogen gas was liberated and NaOH was formed. Do you remember chloralkali process? Yes? No? Very good. Okay. So, what are the two anions we have? Chloride and hydroxyl. So which one gets discharged? So chloride is here and hydroxide is here. OH minus? Yes, pakka? Good job, people. Very good, very good, very good. Come on, give me a high five. Is it clear, everyone? Electrochemical series. The first factor onto which the discharge of ions depends on. Not chloride. Look at the position of both the anions. How to remember electrochemical series? Let's see. I might come up with a song on mnemonics very soon. Till then, practice karo. Now, don't you think it is very much similar to our reactivity series? You need to add in, that's it. है ना? Almost same here. Done. The second factor is concentration of ions in the electrolyte. So obvious hai na? So if an electrolyte has a much higher concentration of a particular ion, so comparatively, so one ion ka concentration is very high, then that ion gets discharged at the relevant electrode. So it doesn't matter, even the other ion is in the lower position of the electrochemical series. So that ion will be discharged at the relevant electrode in preference to those ions who are lower in the electrochemical series but are present along with. Got it? You didn't understand this point? Acha, see. So here we are taking concentrated NaCl. So we just saw the reaction, no? NaCl, you will get aqueous. So dilute NaCl plus Cl minus, H2O hoga obviously, H plus plus OH minus. Here you all told me, ma'am, H plus gets discharged, right? You have told me the answer, hai na? You remember? So what happens here is, as you have taken concentrated NaCl, so obviously the amount of the solute, that is NaCl, is higher in that solution. So when you compare Na plus and H plus ion concentration, Na plus ka concentration zyada hai. So even though H plus is in the lower position in the electrochemical series, Na plus gets discharged. Okay, got it? Yes? So Na plus discharges in preference to H3O plus irrespective of its higher position. See, let's look at the electrochemical series. Na plus is here and H plus is here. So according to electrochemical series and the rules, H plus should get discharged, but because of the higher concentration of Na plus, so it gets discharged at cathode. Okay. So in case of anode, so we have two anions, chloride and OH minus. So both they migrate to the anode, but the concentration of Cl minus is much higher because we have taken the concentrated NaCl solution. So hence chloride gets discharged, although OH minus has the lower position in the electrochemical series. Oh, Mayank, why do protons not come outside nucleus? See dear, first thing, so in order to, okay, so whenever we remove an electron, we are removing an electron from the outermost shell. To remove an electron from outermost shell in an isolated gaseous atom only, we need some energy. Okay, last one. So imagine the proton which is at the center of an atom. You need to, if you have to remove the amount of energy, we cannot supply it. Okay? Yes, which is called as ionization enthalpy or energy. The third factor is the nature of electrodes. So second is clear? Second factor, first and second clear? Yes? Enthalpy, energy is same. It's same. Don't worry about it. Yes? Okay then. So the nature of electrodes used. So we have two different types of electrodes. Inert electrodes which do not take part in electrolytic reaction. Okay, its only job is to give electrons or take electrons from the electrolytic solution. So electrodes used in the process of electrolysis are either inert or active. So example of inert electrodes, we have graphite, platinum electrodes. So they do not take part in the reaction at all. See, in the electrolytic refining and all that, reduction may, so we took the impure copper, thin strip of copper, you remember? Yes? So there, this copper has a part in the reaction. That copper is participating in the electrochemical reaction, but the inert electrodes, they don't. So that's what graphite, platinum are the examples of inert electrodes. Hi Suhana. Okay. So active electrodes, electrodes which will take part in the electrolytic reaction. So different products from inert electrodes are formed. So electrodes like copper, nickel, silver, these are called as active electrodes. So when we compare with the inert electrodes, so if you are taking the active electrodes, so there will be difference in the products formed. How? Let's see. So active electrodes are the one which are taking part in a reaction. For example, I have copper electrode as the cathode. Okay. Then copper gets deposited there. Understood? Hi Vidhi. Hello Keshav. So let's take an example. So in the electrolysis of copper sulfate, we are taking copper electrode. So we are taking copper electrode. So both the cathode and anode are copper. So here what happens, copper is getting deposited at cathode and Cu2 plus is forming at anode. So because both are copper, but CuSO4, in the electrolysis of CuSO4 solution, so obviously water bhi hoga, so Cu2 plus sulfate. So what should happen to this sulfate ion? It has no part here. So but let's compare it with what happens. Let's take an example. What happens if I take an inert electrode? So with an inert platinum electrode, so what is happening? Copper is getting deposited at cathode. Okay, cool. But oxygen gas is getting released. But there, when we took active copper electrode, Cu2 plus was formed at the anode. But when you take an inert electrode like platinum or graphite, so you are getting oxygen, because this is basically a solution, right? So CuSO4, Cu2 plus SO4 minus 2, H2O, H plus OH minus. So this OH minus is getting oxidized to water, oxygen. So this oxygen gas will be liberated. Okay? The second factor is, so if the concentration of a particular ion is higher in that solution, so irrespective of the position of the ions in the electrochemical series, it gets discharged. Okay. So with inert platinum electrodes, there in that case, when we took copper as electrode, active electrode, you got copper at cathode and Cu2 plus ions were formed at anode. But here oxygen is formed at the anode. You're getting the difference? Yes? Okay? Now examples of electrolysis reactions. So electrolysis of molten lead bromide, electrolysis of acidified water, that is water plus some concentrated acid we will add to increase its dissociation. Electrolysis of copper sulfate solution using platinum anode and copper or platinum cathode. Electrolysis of aqueous copper sulfate using copper electrodes. Clear? Pakka? Hi Gaurav. Now let us see what happens. So what are the reactions involved, what are the conditions that has to be maintained in this particular reaction, that is electrolysis of molten lead bromide. So lead bromide is PbBr2. Can you tell me what happens? So it's dissociation. It will be dissociated into what ions? PbBr2 you will get. Clear? All clear? Okay, so good. PbBr2, Pb2 plus, very good, plus Br, that's it, Br. What is Br? Is it bromide ion or Br2 gas? So this is a dissociation. Br minus, very good, Br minus. So let's not look at the reaction first. Now I want you to tell me what happens at cathode. What happens at cathode, people? So we have already studied, right, where the reduction takes place, where the oxidation takes place. Can you tell me? It's okay even if you're wrong. Please don't worry about always getting the answer right and all that. It's completely fine, but give it a try. So what happens at cathode? Pb2 plus goes to cathode, very good. And what type of reaction takes place there? What type of reaction takes place there? Don't know, it's fine. Anyway, I am gonna teach you, but I wanted to know how much you know. It is reduction, very good. It gains electrons, very good. So the 2 electron, okay, because 2 plus hai uska charge. So you will get lead. This is your answer? Yes, people? Pb2 plus goes to cathode, okay, it migrates to cathode, gets reduced there, you will get lead. Done? Right? Okay. Now at anode. What happens at anode? I can write here, no? Br at anode undergoes oxidation and loses 1 electron. Very good. Br minus, you will get Br plus electron, but Br is not stable. So Br2, 2 bromide ions, loses 2 electron and you will get bromine gas. Yes? That's your answer? Pakka? So Pb2 plus, cathode gets reduced, Br minus, anode gets oxidized. Shall we check whether you guys are right or wrong? Before that, what are the conditions? Let's just see. So electrolyte, we are taking molten lead bromide, so it is not aqueous, so you don't have water here. So please be careful, molten state mein, so we are not adding water. So aqueous, molten, there is a difference. Molten state, it is only PbR2. But if it was aqueous, then PbBr2 plus water. Right? Yes, always write the balanced equation all the time. Okay. So electrolyte, molten lead bromide, that is PbR2. PbBr2. Okay. So the temperature, see, lead bromide ka melting point is around 373 point something degrees Celsius. So obviously it should be, the temperature should be maintained in such a way that it will be always in the molten state. Okay, you should keep heating it, because if it becomes solid, we all have studied that solid state mein it does not conduct electricity, it does not allow electricity to go through it, right? So we should always keep heating the furnace in which we have taken the lead bromide. Okay. So electrolytic cell mein, so it is made of silica because it can withstand high temperature. Okay. Molten means it just melts. See, for example, you know, wax. So the solid, and when it gets heated, so it melts, no? Okay. So the cathode and anode both are made of graphite. Okay, inert electrode. It's an inert electrode. Cool. So why we are taking graphite? Because bromine is very reactive, right? We don't want our electrodes to react with the bromine vapors. That is the reason we are taking graphite. So which are inert, they are connected by copper wire to the end of the battery. So current 12 volt and 3 ampere, and ions present Pb2 plus Br minus. Yes, 12 volt, 3 ampere. So from a battery, so they will apply voltage. It's buffering. All good? I don't know. Yes, Pb is lead. Pb is lead. Yes, lead bromide. Not buffering. All good? Okay. So what are the reactions? Let's see. You people are right. Pb2 plus 2 electron. At cathode it gets reduced to lead metal, and at anode Br minus. So it loses an electron. You will get Br. That Br combines. You will get bromine gas, which will be liberated at anode. So see, the lead metal, it gets deposited over the cathode. You can see this is the lead metal which is getting deposited, and from the anode, so the bromine goes towards the anode where it gets oxidized and it will be liberated as bromine gas. Yes? Clear? Hanji, do you want me to explain it again? Got it, everyone? Yep. Okay. So at cathode you will get lead, and at anode bromine gas will be liberated. Very good. Come on, give me a high five. See, you guys were right. Before I taught you, you got the reactions right. See, bromine, lead. Kya baat hai? Very good. So at cathode, Pb2 plus 2 electron, you will get lead. Lead will be deposited onto the cathode, and at anode, so bromine gas will be liberated. So the overall reaction will be PbBr2. So we are not taking aqueous solution, it is molten state, that is almost liquid. So Pb plus Br2. So what were the observations made? See, bromine fumes, so it will be generally brownish in color, reddish brown color. So that will be evolved at anode, and the grayish lead, that is the lead metal, so after getting reduced it will be formed on the cathode. So these are the two observations that can be made while this reaction is taking place, that is electrolysis of molten lead bromide. So note, why are we taking silica? So it is not reactive. We don't want the electrodes and the electrolytic cell to react with the electrolyte, right? So obviously they have to be inert. So it can withstand high temperature, and it is almost a non-conductor of electricity. The silica crucible, so that is whatever the container we are taking, so it will be always continuously, it should be heated, because that 380 degrees Celsius has to be maintained. Yes. Okay. So solid lead bromide is a non-conductor. That is the reason, since its ions are not free. So, and they are, because they are held by electrostatic force of attraction. So it becomes, the ions become free only when it is heated or water is added. So that is the reason. So the crucible is heated from its outside to keep the lead bromide in the molten state. Yes. It's a metal oil. It's not a non-metal. So graphite anode is preferred to other inert electrodes. Why? Because graphite is unaffected by the reactive bromine vapors. We don't want our electrodes to react or get affected by these bromine vapors. Repeat. Which part? Which part, Prithvi? It's a... See, silicon. We are not talking about silicon here. Screen is blur. Is it okay now? So let me just explain this reaction again. So at cathode, the lead ions gets reduced and you will get lead which will be deposited, which is grayish in color. It will be deposited onto the cathode, and at anode, bromine undergoes oxidation, that is loss of electron, and 2 atoms of bromine, because bromine, it is highly unstable, so it cannot exist in the atom form, so it combines with another atom of bromine, and bromine gas, which is almost reddish brown in color, it will be evolved at anode. Okay, so this is it for today, and this is your homework question. What are inert and active electrodes? So what is the difference, and on what factors does the discharge of ions depend? So this you do it at home, and I want you to give me the definition of electrochemical series in the comment section. What is electrochemical series? Okay, so this is what we studied in today's session, that is preferential discharge of ions. In the next session, so we'll look at more examples of electrolysis, how we studied the electrolysis of lead bromide. In the same way, the acidified water electrolysis and more such examples will be studied. I will be taught in the next session, and you will be learning about it. So till then, you know what to do. Keep loving chemistry, elementary chemistry by Vedantu, and do not forget to leave the comments in the comment section. That is it, people. Bye bye. Thank you so much. And if anyone is willing to take up the pro subscription, the link is available in the description as well as in the pinned comment. So use the coupon code SURPRO. Bye bye. Menti आज तो नहीं है. Okay. Take care.